Welcome to this video tutorial where I'm going to show you how to launch an instance of the FORCsensei app on a free cloud service and then show you how to get started with processing your fork data. If you're watching your video, you must have found your way to the FORCsensei website, so all we do now is scroll down to Run FORCsensei on the cloud and click here. We get some information, there's a tutorial video that you're watching at the moment, and then we can launch the FORCsensei on the cloud by clicking this button here. This is going to launch an instance of the FORCsensei app on Binder, which is a free cloud service. If we click show here, we can get some updates on what's happening. So it's just launching at the moment, and this can take a little bit of time, but it shouldn't take too long. The cogs have appeared here. Which show that the server was busy for a moment, but now we're into the FORCsensei app. What we need to do is scroll to the top. There's a little bit of information and then 10 steps that you need to follow in order to do your fork processing. The first thing we need to do before we can start is actually load our data file onto the cloud. And we do this by going up to the Jupyter icon here, giving a right click and saying Open Link in New Tab. Once the new tab appears, we can click on it, and what we're seeing here is a file list of all the files that are on our instance of the cloud here. These are mostly configuration files and so on. But what we need to do is load our data into this cloud drive in order that we can process it. So all I need to do is go to the upload button. I get a normal menu for navigating. I choose the file that I want. In this case, I'm just going to use this one. I say open. You see it's listed the file here, and now I'm just going to click upload. And while this happens, you can see that the data file has now been uploaded onto the cloud. So I can now go back to the FORCsensei app, and we're ready to go. So we just work through the 10 steps. First of all, we want to select a fork data file, so we just say select. And this is a simple panel for choosing the data file. This is it's not showing your local files, this is showing the files on the cloud, and we can just pick up the data file that we just uploaded. And we say select. You can see it's defined the data file here. We now need to initialize the FORCsensei algorithm. Initialize, and it should tell you that the initialization is complete very quickly. And now we're going to select some pre-processing options. Again, we can just open this and say pre-processing options. Some information is pulled directly from the data file, for example the sample name, and then we've got other pre-processing options we can make. And I'll go through these one by one. The first one is, do we want to make a mass correction? Now if a mass is listed in the data file, that will be extracted and entered into the window here. Otherwise, if you didn't have the mass in the data file and you want to perform a mass normalization, you can just type the mass of the sample in here in grams. If you don't want to do a mass normalization, just enter -1. We can also do a linear or a straight line slope correction, just as though we were taking a high field slope correction on a hysteresis loop, and this is the percentage of the maximum applied field from which we're then going to apply a linear fit and perform that high field slope correction. So at the moment it's set to be 70% of the maximum field. That's good for this sample. It's kind of typical when you do hysteresis corrections as well, so we're not going to change that, but you could change it very easily using the slider, or alternatively you could just type the value in you want here. It's always a good idea to do measurement drift correction, and in some cases we do need to remove the first point artifact as well, so I'll click that one. The data file that I'm working with, we don't expect that there's a last point artifact, so I'm not going to click that one. Now that I've got these options selected, I can just pre-process the fork data. I see the little cogs appear up here. That means the server is busy while it's undertaking the calculation. It's loaded the data, it's done that pre-processing. We can see the data in two forms. That's our slope-corrected forks here, the magnetizations, but also the difference forks, the so-called lower branch subtracted forks. This was an idea developed by Raman Egli, who showed that when it comes to doing local regression problems for estimating the derivative, it behaves better if you actually work with these lower branch subtracted forks. One of the problems with this can be if your data is noisy, then doing this calculation amplifies the noise. But as you can see here, there's a little bit of noise, but it's probably not going to be too much of a problem. So we've got this pre-processed data, and now we want to select the model options we're going to work with. So you can see there's a number of tabs, and we'll go through them one by one. This first one is about the regression models. Are we going to work with magnetizations, or are we going to work with the lower branch subtracted data? In this case, we'll work with the lower branch subtracted, so I'm not going to change that. And then we set the range of varifork parameters that we're interested in. SC is the horizontal smoothing factor, SU is the vertical, and lambda is how much the smoothing factor increases as we move towards the extremes of the fork diagram. So the minimum smoothing we'll consider at the moment on the horizontal is 2, the maximum is 8. Similarly on the vertical, minimum of 2, maximum of 8. And lambda will consider values from 0.00 through to 0.08. Now these are kind of the default values that seem to work quite well, and I'm not going to change them. What this means is that we'll be comparing 675 different varifork configurations based on this suite of parameters. So what will happen is, based on that range of parameters, first one set of varifork smoothing parameters will be selected, the fork distribution will be calculated, and then metrics will be calculated to determine how consistent that fork distribution is with the data. Once that's done, then another set of varifork parameters are selected, and again distribution is calculated, and we estimate how consistent the data is with the calculated fork distribution. So we'll be doing this for 675 different varifork configurations and choosing the one where the data is most consistent with the model. If you wanted to change horizontal or vertical smoothing ranges, you can just use the sliders to do that. Downsampling is at how many points we're actually going to perform model comparison in a given fork distribution. So this fork dataset contains about 6,000 data points, but if we were to do the fork comparison of all of those data points, it would take a very long time. So we can actually downsample the dataset so that we're only performing the model comparison at a smaller number of randomly selected locations. To make this quick, I'm actually going to turn this down to 1,000, which again I can do with the slider, or alternatively I can just type it in and hit enter. So that means I'll be doing the model selection process at 1,000 different locations through the fork distribution. For the processing, that's how many different or how many cores we're going to use. This calculation will be performed in parallel. This is less relevant because we're doing it on a cloud service, so we might as well use 4, which is the maximum number of cores available to us on the cloud service. Now that we've got all of this set up, we just need to click the button to compare the different models. So what's happening now, you can see that the little cogs have appeared because the server's busy, and the first set of varifork parameters has been selected. The distribution will be calculated, and this metric comparing the consistency of the data to the model will be selected. Then the next one will go on, and so on. This calculation can actually take a little time, so I'm just going to pause the video until it's finished, and then we'll come back. So what we can see now is that the calculation has completed, and it's output the model results, the optimal varifork smoothing parameters for the horizontal start, the horizontal finish, vertical start, vertical finish, and lambda. There's also a few diagnostic plots. So when we look at the ternary plot here, each of these dots corresponds to one fork distribution calculated with a specific set of varifork parameters. We're looking for the model that gives us the optimal number of cases where the local polynomial regression problem corresponds to a second order surface. That model is automatically identified and coloured in red. That's the model that corresponds to these smoothing factors given up here. We also have the optimal varifork model plotted as a function of these different model orders. So these are the different spaces through the fork distribution space where the given varifork parameters have a tendency to overfit the data, they're given optimal fitting, and they tended to underfit the data. And more explanation of this is provided in the paper. Now we just need to calculate the final model where those varifork parameters will be applied across the entire fork data set. So we just hit the calculate final model button. You can see it just takes a few seconds. And now that's done, we can plot the final fork model. Again, we just hit the button. And an interactive bar appears. You don't see the fork plot at the moment, but as soon as you adjust something on this interactive menu, it'll appear. So for example, if we say we want to include a color scale, we hit the button there and you can see that the fork diagram has appeared. Now, maybe you want to change something in here. You can, for example, change the number of color levels. Do you want to include contours, what the width of those contours should be, and what the dimensions of this box are. So I want to make this box a little bit squarer, so I'm going to reduce the lower limit from minus 0.18 to minus 0.06. I just go in, I change the value, I hit enter, and it will automatically then replot the fork diagram for me based on those new limits. When I'm happy with the appearance of my fork diagram, I can simply click the download plot button, and that will automatically save a version of this fork diagram into the server or onto the server. You can see it's appeared here. What we also have are output files from our pre-processed data, where we saw the magnetization data and the difference forks, also the ternary plot that we looked at, the plot with the different model orders represented by different colors, and now our fork plot. And at any point we could just click on one of those files and say download, and it's automatically downloaded onto our local system. So we can take all of these plots off the server and put them back onto our local system. Now if you want to plot profiles through the fork distribution, again, we just click the Configure Profiles button. You can decide, do you want to plot a horizontal profile or a vertical profile? So in this case, we're just going to plot a horizontal profile. On the vertical axis, it's got a value of 0, and we're going to plot for the full range through the fork distribution. So we're basically plotting a profile that is 0 on the vertical axis and then follows the full range of the horizontal axis. We could of course change this with the sliders as we wish, and when we've made that decision we can say plot profiles, and that profile will appear with its 95% confidence interval. And if we look back on the server space, you can see that profile has now been saved. That image has been saved onto the server, and again we could download that onto our local system simply by clicking on it and selecting the download button. So that's the end of the tutorial. You can see how we can use the free cloud version of the FORCsensei app to process data. It's relatively simple. We just need to set up a few basic model options. An important point to make is that none of the data is saved on the cloud. So when you close the web page off and the cloud instance is shut down, everything that you've done will disappear. So it's important that you download the files if you want them. Of course, it's also no problem if you just start another instance and you can reprocess the data, but it's not possible for you to have a certain personal drive space on the server and for you to save things onto there. So hopefully this was all clear, and good luck with using FORCsensei.